right, grade 5s, we are moving on to our next unit. It has to do with fractions and decimals. We will be working on equivalent fractions, comparing fractions with unlike denominators, describing and representing decimals to the thousandths, relating decimals to fractions, comparing and ordering decimals to the thousandths, and lastly, adding and subtracting decimals. Today, our first lesson has to do with equivalent fractions. All right, our big idea for this unit is knowing what numbers means helps us to compare things and to solve problems. All right, and as I said, our focus for today is equivalent fractions. So let's take a look at a set of equivalent fractions. Here we have, there are 6/12 of the stickers that are left. And she's saying half of the stickers are left. Who is correct? Turn and talk to your group members. Who do you think is right? Is 6/12 more or is 1/2 more? Well, in fact, they are equivalent. Equivalent means the same. They represent the same amount because 6/12 is equal to 1/2. If we have 6 out of 12, that is half of the page of stickers. And for example, if we were to draw this page, and this half is used up, that would be 6/12 left, and it would also be 1/2. All right, so let's take a look at our connect section. Here we have this rectangle, which is made of color tiles. What fraction of the rectangle is green? How many different fractions can you write to describe the green part? Well, if we take a look, there are 12 tiles, so this would be 6/12 of the rectangle. We could group the tiles into groups of 2, at which point there are 3 groups of 2 out of a total of 6 groups of 2, so there would be 3/6 of a rectangle. Remember, when we talk about fractions, the top number, for example 6/12, is the number that we are taking a look at. Might be the shaded number, might be the missing number, whatever the case may be. And the bottom number is always the total amount. So in this case, if we're looking at them in groups of 2, as you can see here, there are 6 groups of 2 all together, making that bottom number 6, and there are 3 of them that are green, making that top number 3. The numerator is 3, the denominator is 6. Now, of course, these are all talking about really the very same picture. They are just divided differently, so they are the same amount. They are equivalent fractions. It's just looking at the information or the picture in a slightly different way. We could also look at this information with groups of 3. And if we were to look at it in groups of 3, there are now 4 groups of 3, which makes our bottom number 4. 2 complete groups are green, so that would make it 2/4. Also, still talking about the exact same amount. Lastly, we could look at it as 2 groups, and one of the 2 groups is green. So this whole entire group, that would be 1/2. Therefore, looking at this picture and seeing how it's been divided differently, all of these fractions, 1/2, 2/4, 3/6, and 6/12, are all discussing the same amount. They are considered equivalent fractions. Remember, equivalent means equal or the same fractions. And again, equivalent, you can almost see the word equal right in that word. Here we can even see that there are patterns in this equivalent set of fractions. The top numbers are multiples of the least numerator, which is 1. The denominators are multiples of the least denominator, which is 2. 2, 4, 6, 12, and so on. Sometimes when we look at fractions, we use a set. So it's not one item divided into different amounts of pieces. It's a set of items. So for example, here we're going to look at this set of items. And we can see that there is 1, 2, 3, 4, 5, 6, 7, 8 sets of 1, 2, 3, 4, 5. 8 sets of 5 means there's a total of 40 dots here. And if we wanted to consider how many are red, we would be looking at 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 sets of 6. 6 sets of 6? 1, 2, 3, 4, 5 sets of 6, which would be 30 out of 40. We could combine those sets into groups of 8, which is what they've done in this picture. And in that case, we would have 6 eighths in a set. Okay. One of the ways that we can find equivalent fractions is to multiply by the same number for the top and the bottom. Or another way is to divide the same number with the top and the bottom, with the numerator and the denominator. So let's check this out and see how it actually works. Okay, so if I have 6 eighths and I want to give 6 eighths to 5 different friends, I need to now see how much I was going to have. So I'm going to times 5 to each side. Well, 6 times 5 is 30, that stays my top number, and 8 times 5 is 40, and that becomes my bottom number. So 30 40ths is an equivalent fraction. I could multiply it by another number too if I wanted to. I could go 6 eighths. Maybe I only want 2 sets for me and my best friend. I'm going to times by 2. 6 times 2 is 12. 8 times 2 is 16. So that would also be an equivalent fraction. Sometimes our equivalent fraction gets smaller. It's not always possible if it's already the smallest possible fraction, but with 6 eighths it is possible. We can divide both of these numbers by one number. 6 can be divided by 2 and it can be divided by 3. 8 can be divided by 2 and it can be divided by 4. So both can be divided by 2. So I'm going to divide both by 2. 6 divided by 2 is 2. 8 divided by 2 is, 6 divided by 2 is 3, my goodness. 8 divided by 2 is 4. So 3/4 is also an equivalent fraction. When you multiply or divide the numerator and the denominator of a fraction by the same number, that's the key thing there, they have to be the same number, you do not actually change the value of the fraction. You are just changing the way that it is divided. Therefore, 3/4, 6 eighths, 12 16ths, and 30 40ths are all equivalent fractions. All right, so just to review, to find equivalent fractions, you multiply both numbers, the top and the bottom, by the same number, or you can divide them. So we're going to do some practice. We're going to try to find equivalent fractions for these numbers, and I'm going to write them down for you. So one moment. All right, so we're going to start with our first equivalent fraction. And when we look at an equivalent fraction, what we look for is, what did we do to this number to get to this number? And it has to be multiplication or division. It cannot be adding or subtracting. It has to be multiplying or dividing. So what could I do to the 1 to get to the 3? Well, it's getting bigger, so I'm probably multiplying, and I can multiply by 3. Whatever I do to the top, I also have to do to the bottom. So I'm going to times 3 on the bottom. 5 times 3 is 15. I've now created an equivalent fraction. 1/5 is equivalent to 3/15. You now need to do the same thing with these ones. So press pause and try these on your paper, please. All right, now let's take a look at what you did. So what you should have noticed here is to get from 10 to 20, you would have to multiply by 2. And then we have to multiply by 2 as well up top. So 1 times 2 is 2. The equivalent fraction to 1/10 would be 2/20. Let's take a look at this next one. 3/4 is equal to how many 9 over what? We look 3 times 3 can be 9. So again, what I do to the top, I also have to do to the bottom. So I'm going to multiply by 3. 4 times 3 is 12. So 9/12 is equivalent to 3/4. 1/3. We're trying to find an equivalent fraction out of 12. So I'm going to look at 3 and 12. What times 3 equals 12? 3 times 4. And again, what I do to the top, to the bottom, I have to do to the top. So 1 times 4 is 4. 4/12 is equivalent to 1/3. And the last one that you had to do, 2/4 is equivalent to 8 what? 2 times what is going to be 8? Well, 2 times 4 is going to be 8. So we're going to have to multiply by 4 on the bottom. 4 times 4 is 16. So 2/4 is equivalent to 8/16. All right, now we're going to try some where it's getting smaller. Now remember, to create equivalent fractions, we have to either multiply or divide. So if I'm looking at this fraction here, and I want to make an equivalent fraction with 3 as the denominator, 9, what would I do to the 9 to get to the 3? Well, it's getting smaller, so I'm probably going to divide. Well, if I look at it, 9 divided by what is going to be 3? Well, 9 divided by 3. And just like before, what we do to the bottom, we also have to do to the top. So I'm going to divide by 3. 6 divided by 3 is 2. So the equivalent fractions then are 2/3 and 6/9. Press pause and try the other 3 on your paper. All right, let's take a look at what you've got. So if we look at 6 and it's trying to become 3, so I would have to divide by 2. And again, what I do to the bottom, or to the top in this case, I also have to do to the bottom. Same thing to both sides. 12 divided by 2 is 6. So 3/6 is equivalent to 6/12. 8/10, and I want to make it equivalent to something over top of a 5, with 5 as a denominator. So 10 divided by what is 5? Well, 10 divided by 2 is 5. So again, I'm going to have to divide by 2 up here. 8 divided by 2 is 4. So 4/5 is equivalent to 8/10. Let's take a look at the biggest fraction here, 40 and 48. And in fact, we could divide by lots of things in this case because there's lots of common factors between 40 and 48. So common factors is a good connecting concept because really we could divide both of these by 2. We could divide both of these by a number of different numbers. Let's take a look, though. To get from 48 to 6, I'm going to have to divide by 8. So I'm going to do the same thing on the top, divide by 8. And 40 divided by 8 is 5. So 5/6 is equivalent to 40/48. All right, let's say you were asked to create an equivalent fraction, and it's an open question, and you can create whatever equivalent fraction you want. Well, if we have a fairly large fraction, we generally can make it smaller, and sometimes even they'll ask for a fraction to be in its simplest form or in simplest terms, which means you need to make it as small as it can possibly get. So let's take a look at what we can do with this fraction. So for example, we've already realized they both divide by 8. Okay, multiples of 8, or both of them have 8 as a factor. Well, we could use our factors actually to figure it out. Okay, well, factors of 40, I can have 1 and 40. That doesn't change the number, so it helps me not at all. I can have 2 and 20. 3 and nothing. 4 and 10. I'm running out of room there. I'm going to have to write it over on this side here. And 8 and 5. Those are all the factors of 40. So that means it can be divided by any of those numbers. Well, let's see what the factors of 48 are. Again, I can have 1 and 48. 2 and something should work because 48 is an even number, so it's divisible by 2. What is 48 divided by 2? 24. 3 is unlikely, but we'll give it a try. Oh, yes, it works. 3 and 16. There we go. Okay, 4 and something should work. One moment. All right, and of course it should work by 4. 4 and 12. 5, nope, because it doesn't end in 0 and 5. 6, yes, 6 and 8. And there we go. We have all of the ways that we can divide these numbers. So we could divide by 2. 40 divided by 2 would be 20. 48 divided by 2 would be 24. So 20 24ths is equivalent. We could also divide by 4. 40 divided by 4 is, 10. Let me erase that. Make it clear. 10 over 16. What else could we use? We could also use 8, it looks like, is our last possibility. So, again, that was 6/8. So these are all of the equivalent fractions that we can make, making it a smaller fraction. And this would be the fraction in its simplest terms or simplest form. We could, of course, also make this fraction equivalent by multiplying. Let's say I decided I was going to multiply by 2, for example. 40 times 2 is 80, quite a big number. 48 times 2 is going to be a really big number, a fairly big number. 40 times 2 is 80, of course, and 16 for 8 times 2, 80 plus 16 makes that 96. So 80/96 would be an equivalent fraction. And bigger, I could keep going. I could multiply by 3, I could multiply by 4, I could multiply by 6, whatever I wanted to. Okay, so that's how you can create equivalent fractions. All right, we're now moving on to the concept practice for equivalent fractions, and I've changed the numbers that you're going to do a little bit. You're going to do questions 2, 6, 7, 9, and 10. Some of the questions ask you to use counters or to use base 10 blocks or whatever. You don't have to if you don't want to. I'm a big believer in you using whichever strategy works best for you. So feel free to use whichever strategy you prefer in this case. Your goal, of course, is to find equivalent fractions or to determine if fractions are equivalent. So away you go. I will attach the textbook pages just in case you've forgotten your textbook when you're doing this at home. All right, here's your first set of questions. Press pause if you're working on these. And your second set of questions, press pause if you're working on these. And your last set of questions, press pause if you're working on these. Make sure as you go along, if you have questions, that you let me know. Good luck.